Hi everyone, it's Mrs. Summer here to talk about particle to mole conversions. In this lesson, the goals are to convert particles of a substance to moles of that same substance using Avogadro's number. Remember how to enter things with your calculator. You need to use the E means times 10. So when you are entering in your calculator, you need to hit, if you're entering 5.6 times 10 to the 23rd, you need to hit 5.6 second E to the 23rd, and that will give you the same number. And the benefit is it will keep it as one number and it won't separate them into 5.6 and then times 10 to the 23rd power. So when multiplying or dividing using scientific notation, make sure the scientific notation goes in the parentheses. Double check to see if you have scientific notation in your answer. So if there is an E here, if you look here, there's an E, it means 1.56 times e to the negative 16 is 1.56 times 10 to the negative 16. Don't just write 1.56. It's a common error I have seen students make. Also, in your answer, do not write E. You write times 10 to the whatever power it is. You recall, since Avogadro's number is equal to 1 mole, it will be the conversion factor between moles and particles. So 1 mole is equal to 6.02 times 10 to the 23rd particles. Particles can be ions, atoms, or molecules. So we can write our conversion factors as 6.02 times 10 to the 23rd particles over 1 mole, or 1 mole over 6.02 times 10 to the 23rd particles. So this question is, how many moles of M3N2 are in 8.52 times 10 to the 24th molecules of M3N2? So what we first have to do is figure out our given. Our given is here, and so that's going to go in this upper left-hand box. So we have 8.5 times 10 to the 24th molecules of M3N2. Then we're going, so if we're getting rid of molecules, our Avogadro number now goes on the bottom. Molecules of M3N2, and our 1 mole goes on top. And so when we cancel our molecules, we are left with the answer of 14.12 mole M3N2. You try. How many moles of H2SO4 are in 1.5 times 10 to the 21st molecules of H2SO4? So in this question, 1.5 times 10 to the 21st molecules is our given. So we need to put our 1.5 times 10 to the 21st molecules, H2SO4, over here. And since we are starting with molecules, our Avogadro number goes on the bottom. Molecules, H2SO4, and our 1 mole, H2SO4, goes on top. And when we calculate that, we get the answer of 2.49 times 10 to the negative 3rd moles H2SO4.